Our sun looks nothing like this. It looks more like this. If you've always thought our sun was a bright yellow ball of fire, you were wrong. For starters, it's not yellow, it's green. Scientists determine the temperature of a star by the color spectrum it emits. Each color has its wavelength, and astronomers measure it to determine how hot a lead is. More excellent stars appear red, while the hottest stars look blue. Our sun emits most of its energy at a wavelength close to the green. But because it also emits other wavelengths, all these colors mix, and your eyes see this vibrant mixture as white. That is if you look at the sun from the International Space Station. From here on Earth, the sun looks yellow because our atmosphere is good at scattering blue light. Without the blue wavelength, all the other colors combine into yellow. If our star were yellow, it would be about 800 degrees Celsius, 1,400 degrees Fahrenheit, cooler, and our solar system's habitable zone would shrink, making Earth a frozen, lifeless rock. But there are other things you are wrong about. The sun is hot, but it's not on fire. Burning is a chemical reaction of oxygen with fuel. Like most stars, our sun is a ball of gas, mostly hydrogen and helium. It doesn't have much oxygen in it. Instead, it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy, and that's why the sun is so scorching hot. Speaking of setting things on fire, let me tell you about explosions in space. Yeah, these aren't real. A spaceship can't go down in a violent blast because there is no air in space. No air means no oxygen. As you already know, no oxygen means no fire. Sorry, Star Wars fans. It may seem that there are too many stars in the night sky for you to count, but actually, you can. However, scientists at Harvard have already done it for you. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the naked eye. Try to count them all for yourself. Movies make it look like you must be an extremely skilled pilot to navigate the asteroid belt. But that's not true. The asteroid belt isn't some thick obstacle course of death. It does have trillions of space rocks that range in size from space dust to a quarter of the size of the moon. About 100,000 of these asteroids are over 1 kilometer, 0.6 miles, wide. But they're very spread out. The asteroid belt between Mars and Jupiter is 225 million kilometer, 140 million mile, across, 1.5 times the distance between Earth and the Sun. This spreads the space rocks millions of kilometers apart, making it almost impossible for a spacecraft to collide with one. If you were thrown out of the airlock into the vastness of space, you wouldn't turn into a popsicle immediately. That's because to freeze, there has to be a heat transfer from space to your body. But heat or cold doesn't travel very fast in the vacuum of space. Your body would freeze, but it would take hours to happen. And by then, you'd be long dead from something else. And no, you wouldn't explode in space, either. You would inflate, though. That's because nitrogen in your bloodstream would gather into bubbles and puff you up to double your size. But that's not what's going to kill you. It's the lack of oxygen. After 15 seconds in space, your brain would not get enough oxygen through your blood, and you'd lose consciousness. After 2 minutes in space, your other organs would shut down one by one. Game over. Space seems incredibly cold, but it's not. In reality, space doesn't have a temperature at all. Temperature is defined by the speed at which particles move and the amount of energy they have. In the actual vacuum of space, there are no particles to move around, which is why space is temperatureless. Of course, outer space isn't a perfect vacuum. It still has particles and radiation that produce heat. Some areas of space are hot, like the space around stars. But the further away you get from celebrities, the more spread out the particles are, making those space areas chilly. Some dense gas clouds can get as cold as minus 263 degrees Celsius, minus 440 degrees Fahrenheit. Mercury is the closest planet to the Sun, But surprisingly, it's not the hottest. It is extreme, though. During the day, its surface temperature reaches 430 degrees Celsius, 800 degrees Fahrenheit. At night, it drops to minus 180 degrees Celsius, minus 290 degrees Fahrenheit. Oof. But the most hellish planet in the solar system is Venus. You see, Mercury doesn't have an atmosphere to retain all that heat from the sun. On the other hand, the Venusian atmosphere is very thick, creating a greenhouse effect. It's like global warming on steroids, making Venus a hot hell with a surface temperature of about 475 degrees Celsius, 900 degrees Fahrenheit. Our entire solar system isn't just sitting in one spot in our galaxy, it's hurtling through space at 220 kilometers per second, 140 miles per second, which is 7 times faster than the speed at which Earth revolves around the Sun. Our solar system takes 230 million years to make one orbit around the Milky Way. The last time we were in our exact location, Earth had one supercontinent, and the dinosaurs were starting to roam around. Planets do not orbit around the Sun. Instead, everything in our solar system is in balance, and other planets participate in this gravitational tug-of-war. Instead of orbiting the Sun, planets and moons orbit around a central point between them and our star. This point is called the barycenter. This barycenter is so close to the Sun's core that there's not much of a difference for Earth. But for Jupiter, this point is about 55,000 kilometers, 35,000 miles, away from the center of the Sun, so the gas giant and the Sun are orbiting each other. Earth appears round from space, but it's an irregularly shaped ellipsoid. It bulges at the equator due to the centrifugal force caused by our planet's spin. As a result, Earth is about 43 kilometers, 27 miles, wider at the equator than at the poles. This makes gravity at the bulge slightly weaker, making it easier to launch spaceships from the equatorial regions than from the poles. In space, no one can hear you scream. That's only true to a point. Sound needs a medium to travel through. In space, molecules are very far apart, so the sounds fade before they can get very far. All the cosmic catastrophes, supernovas, and colliding black holes go quiet before you can hear them. But some places in space have a lot of particles for sound to travel through, like the hot gas cloud around the black hole at the center of the Perseus galaxy cluster. It has so much gas that you can hear the black hole. You know, other planets make noise too. Do you know what they would sound like if you could listen to them? Well, that's a story for another Helpline video.